So the work I do, Pancharatnam verifies, plays an important role there. So that's why I thought it was nice that I was giving this Pancharatnam lecture. The other thing I find nice here is that they are building pockets of excellence. So they are not going after everything, but they have some themes and they want to create some critical mass within each theme so things can explode. And the kind of research people are doing here is very exciting. At Raman Institute, my first work was on Raman scattering. The puzzle was that there are these niobium diselenide superconductors. It was a well-known result in superconductivity that you cannot see the gap through Raman scattering. But these superconductors do show a peak in the gap, which I think was a very good problem now, but I got sidetracked, I did something else. Recently I met my thesis advisor, Phil Allen, and I said to him, I apologize for not doing exactly the problem that you gave me. He told me that one of the best decisions he made was to let me work on whatever I wanted to do. When I was working on the problem of fractal quantum Hall effect, it was widely understood to be a pretty amazing puzzle. So initially, several people were very vehemently opposed to the model. Several of my mentors gave me the advice that I have to work harder. It's good that it was not accepted immediately because I had to prove it more rigorously than I would have had otherwise. It's grown into directions that I could never have foreseen. If somebody had told me, look, you can see a fractal Hall effect without any magnetic field, just a few years ago I would have said, you're crazy. I would have bet my year's salary on that, but now they have seen it. That's very surprising, and then you say, okay, let me try to understand that better. And this was not predicted, so it came out of nowhere. So it's been pretty amazing, I would say, and very fulfilling.